Hello everybody. In this video we are going to see greatest common divisor finding using Euclidean method of recursion in Python programming language. So what is GCD, or you can say greatest common divisor? So if you are given two numbers, you're working with two numbers. If you're given two numbers, which number divides these two numbers without any remainder? That is said to be a divisor. So in that case, there can be many divisors possible for two numbers. So as in this case, if you take 32 and 16, 1, 2, 4, 8, 16, all these numbers will divide 32 and 16 without any remainder. But the biggest one is 16, which divides these two numbers without any remainder. So that is called greatest common divisor. If you take this example, the last one, 30 and 45, the greatest common divisor is 15. 15 divides 30 and 45 without any remainder. 15 is the greatest common divisor. You don't have any other thing which is greater than 15 which divides 30 and 45. So likewise, we have a Gcd finding mechanism. We have usually used to do in the iterative mechanism, but Euclid has proposed a solution using a recursive logic. So how that logic works? So you have to take the larger number and you have to divide that larger number with a smaller number. Once you are given two numbers, find the larger number in that two. Then divide that number with a smaller number. Then the remainder you will get. You keep the remainder. If the remainder is equal to 0, then just tell that smaller number, that denominator 1 that divides that larger number which is giving a remainder 0, that is the GCD. Here, if the remainder is 0, which has divided this larger number by giving a remainder 0, that smaller number is the GCD. That's the end of the logic. But if this is not equal to 0, you have to go to the else part, where you just have to assign the larger number by the smaller number. That is, you are replacing larger number with a smaller number, the smaller integer. That is, numerator is replaced by the denominator. The denominator, which is the smaller integer, will be replaced by the remainder. Then again we have to go to the step 1 to find the remainder. So this logic continues till this is 0, no exit is possible. So remainder should come to 0. So there is a recursive logic, obviously. But the recursive logic needs a stopping condition. What is the worst case? Worst case is if the number reaches 1, the remainder will be 0. Because 1 divides any number, any integer with a 0 remainder. So at that time we will be stopping this. So this is the stopping condition for this recursion. And this is a subproblem. Why we say it's a subproblem? Because we are replacing the larger number by the smaller number. The smaller number is replaced by the remainder. So if you are having a denominator, the denominator is replaced by the remainder. The remainder will be smaller than the denominator, obviously. So the problem size is reduced at every step. So I'll give an example, you will understand more clearly seeing an example. Say for example, we have this 45, or you can go to this one, 24 and 10 we got. This is a larger number and this is a smaller number. We are dividing larger by the smaller. The remainder is 4. It is not equal to 0. That means we have to continue the recursive logic. So the smaller number becomes the numerator. The remainder becomes the smaller number. That is the denominator. Now you see, the larger number is replaced by the denominator, which is a smaller number. Obviously, larger number size, the numerator size reduced in the step 2. The denominator is replaced by the remainder. The remainder cannot be more than the divisor. When the divisor is 10, the possible remainders are 0 to 9. That means it cannot be more than 9. That is, it will never be equal to 10. So this denominator is also reducing in size. So every time we are reducing the numerator size and denominator size. All the way it comes down. When we reach a 0, we are stopping. So here 2 remainder is there. That means we have to continue. 4 becomes the numerator, 2 becomes the denominator, we got 0. So we stop it, and this is the GCD. But in this case, if you see, if I take 59 and 12, remainder is 11. If I divide numerator by denominator, the remainder is 11. Now it is non-zero, so 12 goes to the numerator, remainder comes to the denominator. Now the remainder is 1. It is still non-zero, so 11 goes here, 1 comes here. This is the 0 remainder, so GCD is 1. So the worst case we hit is GCD 1 will happen. Okay, for the worst case, if there is a prime number. See, if there is a 59 is a prime number, so that's why we are getting 1 in this case with the combination of with the 12. But if you have 59, then it will be different. Or 59 into 2, twice the 59, then 59 will be the GCD. So if you take the first example here, 44, 22 directly divides the 22 divides 44 with the remainder 0. That means GCD is 22. 22 divides 44 and 22. So GCD is 22. If you take 45 and 30, GCD is 15. So we are getting 15 remainder. Next time 30 goes here, 15 comes here, we got 0. So 15 is the remainder. And then 44, 33, remainder is 11. 33 goes here, 11 comes here, 33 by 11, we got 0. So remainder is, the GCD is 11 here. So these are all some examples we have seen. So now we are going to implement this logic in Python. So if I want to write, as I told you, we are dividing larger by smaller. Okay. So for example, we have this 24, 10 example. A is 24, B is 10. I'm going to write a function which is GCD. I'm going to pass A and B to that function. So first we'll write a function GCD. GCD, it gets large and small here. So I'm passing this A, which is the largest number out of these two, and it's stored in large. B is 10, it is smaller than 24, it is stored in small. So we are starting in the right track. We are going to divide the larger number with the smaller integer. So in here I'm going to do remainder equal to large percentile small. So we got the remainder now. If the remainder is equal to 0, equal to 0, what we have to do, we just have to return the value small as an answer, because GCD is the smaller one, the denominator one. Else what to do? If it is not equal to 0, what we have to do, we have to just assign the larger with the smaller with the remainder. Then we have to go to step 1. That means we are just going to start the division process again, but with the changed values. So as you see, the smaller number becomes the larger, remainder becomes the smaller. Okay, so here what we have to do, we have to call GCD. We have to call GCD, and then to the GCD what we have to pass small. Here in this function, whichever is small will be stored as a large. This is a recursive call. I am calling the function again, same. This is a recursion starts here, small, and the remainder will be going and getting stored in the small. So small is becoming the numerator. The remainder I am getting, if it is not equal to 0, the remainder I am getting, it is stored in small. Okay, so here it has to be returned. So if you're getting 0, you return this value. Okay, how this return mechanism works, you see this one, 24, 10. Okay, we are just passing this one only, 24, 10. So what is happening? Remainder is 4. It is going here. Remainder is 4. Is it equal to 0? No. That means it will come here. Return GCD small. So it is a function call. So function call should finish. Then the value will be here. That value will only be returned to the caller. Who calls this one? This place calls. So here I am going to put a print. So in this place the answer will be printed. So this is coming here. So it is originating a one function call. So this function is not over. This function, this line you are seeing now, where large is 24, small is 10, this is not over because it has to return. So it is waiting for this function call. This new function call originated. So now it goes here. What it is passing? It is passing small as large. So small number here, which is small number here? 10. That is stored as large in the next function, the second line. Now remainder here, which is 4, will be passed as a small. Now the new function originated. Now this is the birth of the second function alive. First one is still not over, but this is over that first one. This is alive now. This will return to the first one. Then first one will return to the main call. So 10 4 is happening. Now 10 by 4. Reminder is 2. Is it equal to 0? No. That means I am going to return GCD small. Here small is 4. Okay, small is 4. 4 is now again passed as a large to the next function. So 4 goes here. And the remainder of this one, which is a 2, will be passed as a small. So next function is originated. So this is also not over. This is also not over. It has to return. This also has to return. So this function is now going on. 4. Now this is 4. 4. Reminder. This is 2. Reminder is 0 now. Now it will go here. It will return small. What is small? 2. So to whom it will return? This function. Who called this third line? This second line called it. So it will return here. So that means this place it will come, the 2 value will come. So it will return to this one because it got the value 2. The function call is over. The 2 will be returned here, and that will also be here waiting here. That will return to this one, the main function call. So 2 will be printed here. So this is the way it unwinds itself. Recursive calls of function is happening. So if we see 2 is printed over here. So if I put 30 and 10, the greatest common divisor is 10, that is printed. If I putting say 30 and 60, you have to be very careful because what I'm passing A is a bigger one, but here you can just say 60 30. You pass the first one which is bigger here. Okay, so here 30 will be the GCD. So you can write one thing, whichever is max you can find out and you can pass it as a first value. So this is the logic of recursion, Euclidean recursion logic for finding GCD numbers. So the algorithm is here. I hope you have understood. Thank you.